Hello everyone, welcome back to another Hippo tutorial, and in this video I'm going to show you how we can implement pagination to your own Android app. So let's get started. So why do we need pagination at the first place? Imagine you have an Android app and you want to fetch some data from a remote resource. It can be API, it can be a database or something else. So let's imagine this is a set of data that we want to fetch from the API. Let's say there is at least 100 pages for book and in total 300 pages in this set. If I try to get all of them at the same time and start to read them, it may be too much for me and I may not be able to handle it. This is the same case for our Android apps. When you are trying to fetch so big amount of data at the same time, it can make your app slower and slower. So what is the solution? Implementing pagination. Leave these 300 pages at the database and do not touch them at the same time. Let's say you want the data. Just get one book at a time. Start to read it. It is so light. It's only 100 pages. And once you finish it, leave this aside and get another book. This is what pagination does in our Android apps. So by doing so, you can make your Android app more efficient and it will work much more faster. All right, now we can continue with implementation. Let me first start screen sharing. Okay, I think you can see my screen right now. So I created a demo app in order to show the implementation. So let's see the app. Okay, this is Pagination demo app. It is a very simple application which shows the passengers of a flight. As you can see, we have two recycler views. One is horizontal and one is vertical. And when you slide to the right or left, as you can see, there are more and more passengers. And it looks like it is infinite. But in reality, at the background, there is a pagination library that we're using, which fetches data when there is no more to see. At the same time, same pagination is implemented at the bottom recycler view. If you go down and down, it looks like there are like tens, maybe hundreds of passengers. As you can see, it looks infinite. But in reality, we fetch only 5 passengers at a time. So this is all about the app actually. In this tutorial, I'm not going to mention about these designs. It is not the topic of this video, but if you are interested of this card design and colors and so on, you can check the code. It is very easy. Okay, so let's move into the code. So I open first build.gradle file because as you can see, we are implementing pagination library, paging 301. We also have another components like network, health, navigation, lifecycle, and these default ones. I'm not going to touch those neither because these are so different modules and maybe there will be different videos for these components in the future. But only thing you need to know for this file is implementing paging library right here. Now we are seeing the documentation. It's very short. You can go and read the whole, but let's touch to some of them. This is what I showed you in build.gradle, implementing the paging library 301, as I also did. I use KTX extension for Kotlin, but you can also use the normal one. There's not a big difference, but if you're using Kotlin, KTX is the way to go. And this model is actually important, which we are going to talk a little bit. So we have repository, ViewModel, and UI. So let's start by the repository. There's 2 options you can choose from, PagingSource and Remote Mediator. If you are going to fetch data from only one resource, let's say an API or database, PagingSource is enough for you. But let's say you need 2 different data, one from API and one from database, and you are going to combine them, create another item, and do something else, then you should implement Remote Mediator. in this demo app, I try to keep it as simple as possible. So we are using PagingSource, but if you want, just come to this website and read about remote mediator. They are not very different from each other. And in ViewModel, we have a pager object. A pager object gets a paging source or a remote mediator, and it gets more components. We tell how paging should work, and it can be converted into flow, which is very important because we are going to collect this flow in our UI, submit the data to a paging data adapter, which is similar with an adapter, but it is specific for our paging library. Then our adapter can update our recycler view. So let's go back to our code and start with passengers paging source. So let me explain what is a paging source. Paging source is the file where we tell our paging library where to fetch data from and how. We have two important functions, which is load and get refresh key. And in this part, I'm going to explain each line one by one. Okay, so from the load function, we are going to return a load result. If we could successfully fetch the data, we are going to return a page. But if we could not do it, we are going to return an error so that our paging library will be notified. So we are getting page and size at that point because our paging API is supporting page and size as parameters. We are providing those in the link. But in some APIs, maybe there is not page and page size as parameters, but it returns the next URL. This is also a very common use case. But for the API that we are using, we need to send these parameters. And this is actually the reason why we are using integer as a key. If the API is returning the next URL, you should consider using string. But again, it's very simple. And after this tutorial, you will be able to implement these APIs too. So we are getting page and size. I'm not going to, touch the params right now. I will come back to that. But imagine we have page and size. Then in return, we are using our passenger API and passing this page and size as parameters, as I said, and we are getting the response. Then we are telling like passengers is the data. And this logic is important. We need to pass next key and previous key to the page that we are returning so that paging library can calculate the next key, previous key, and do calculations accordingly. So how do we calculate next key? If the passengers is empty, that the result that we took from the API is empty, it means that there is no more data to be fetched from. So we need to return null in the next key. If it is not null, we need to add 1, and in the next load function, and in the next time load function gets called, we are going to get the next page. For the previous key, again, if the page is the first page index, it means we just started, so there is no previous key, so we return null. If it is not the case, we need to get the page, subtract 1, subtract 1, subtract 1, and make it the previous key. Then we are passing our data, passengers, previous key, and next key in page and returning it. Let's say there was a problem when we were fetching data from the API, which means our try catch function would fall into the catch. If it's an IO exception or HTTP exception, it would return this error, and we can also handle them in future. So let's go back to the key. At first, our key is null until you give a value. So we are saying if the key is null, just start by the first page index, which is defined at the bottom of the page. Our API start from 0. Sometimes they may start from 1 or maybe even -1. So be careful. Look at the API and see which page is the first page of the API. In our case, it is 0. So we are passing 0. But next time load function gets called, since we gave next key will be our key for the next load function. So key will not be null, and page will be next key that we passed previously. If you look at the size, which is page size actually, which means how many passengers we need to fetch from the API in each request. We are getting it from params.load_size, but as you can see, there is no load size defined in this file. The reason is that this is given in the pager. So PagingSource object gets this parameter from the pager, which we are going to pass in the next file, and I'm going to show it. So what is getRefreshKey function? It is the function where we are calculating the current page. As you can see, we are checking if the previous key is defined at 1, which means the current page, or if it's not defined because it can be null, as I explained above, take the next key and subtract 1. In this way, you can calculate the current page. And again, it is automatically used by the paging library. You don't have to worry about where I'm going to use this. Just implement the body and you are good to go. All right, I think we are done with the paging source. Now we can move to the pager. So let's see where we are using this passenger paging source. In passenger repository, if we remember our model, we need a pager in ViewModel, but who provides this pager to the ViewModel? In our implementation, the repository. So I create the pager in repository level, then pass it to the ViewModel. So how do we create the pager? It is very simple, actually much more simple than PagingSource. So we create a pager object, and it gets 2 parameters. One is config and one is PagingSource factory. PagingSource factory is the parameter that we are passing our PagingSource. It is very simple. As you can see, we are creating our PagingSource with the passenger API and passing it as a parameter. And in config, as I explained before, we are providing the page size, initial load size, and if we want to enable placeholders or not. Placeholder, let's start with placeholder, is important when, let's say we lose internet connection, then our paging library shows some placeholders instead of the objects, but we don't use it in this project. But if you need it, it's a good feature. Initial load size is the first number of pages that we are going to fetch from the API in the first initial request. Right now, it is just the page size, but by default, it is a triple of your page size. So if you do not provide this data, it is going to get, let's say our our passenger page size is 5, and in the initial request, it is going to take 15 passengers. Then it will continue with 5 and 5. But we don't want this. We are going to provide that initial load size is passenger's page size. So each request will get 5 passengers at a time. And page size, as I explained, is the regular page size, which is provided to PagingSource as a parameter. So it's very simple. We create our pager. So it is time to pass this pager to the ViewModel. And here is our ViewModel. We are using a getPassenger method, and it returns a flow of paging data. But from our repository, we only get a pager object. So we need to convert this to a flow. GetPassenger page after this function, after this method, we are calling this flow method. But also it is we are able to get this as live data, but we are using flow for this tutorial. And after this flow, it is converted into flow, and we are caching it in ViewModel scope for storing data. So if we go back again to our documentation, we create our paging source. In ViewModel, we had a pager, and we also converted this pager into a flow of paging data. And now what we need to do is take this flow in UI and collect it. So let's see where this getPassengers method is called in home fragment. All right. Now, as you can see, we have 2 different adapters because in our application, we have 2 different, as you can see, 2 different recycler views. So we implemented 2 different adapters. One is for horizontal and one is for vertical. And again, here we are setting their adapters. And in getPassengers methods, we need to create 2 different asynchronous functions in order to collect this data and pass them to their adapters. So we are calling getPassenger method here, which returns a flow. Then we collect this flow and submit this data to their own adapters. It is very simple. As you can see, our home fragment is very short. And also we are calling this get passenger method on we have created. Very simple. Binding whole ViewModel, these are very simple. I think there's nothing else to explain right here. There's an unnecessary blank line, and let's remove that too. All right, so what we need to move next is our adapter. Let's go to the adapter. And okay, we have two different adapters. One is horizontal passengers adapter, and another one is vertical passenger adapter. They are almost the same, but their bind methods are a little bit different because, as you can see, there are different components in their designs. For example, vertical card one has a logo, but the other one does not have. So we created two different adapters for them, but explaining only one will be enough. So horizontal passenger adapter, which extends paging data adapter. It is almost same, almost identical with normal data adapter, but it is specific for paging. So we need to use this paging data adapter. These are actually the same. On create view holder, just a simple recycler view implementation here. And let's go to our bind method. We are getting data as passenger response, and we are passing it in the design in our UI. We are loading it, and there is nothing else, as you can see. And even our view holder is not specific for paging. It is a normal recycler view.view holder. So after you did all of those, and of course, there are some other components, as I mentioned before, like retrofit, like dependency injection with hilt or dagger, some utils, but these are some side components that we are not going to talk in this tutorial. And as you can see, just by creating a simple paging source, then passing it to a pager, then converting it into a flow and collecting it in a UI, and then submitting this data into a paging data adapter is just enough for creating this application. Okay, so before we finish our implementation, I want to be sure that our paging is working correctly. So in order to do so, I want to check the logcat. So let's go back to our Android Studio, and this is the end of our logcat. And as you can see, the last page we fetched was page number 2 with size 5. So let me make this smaller in order to see both of them at the same time. Okay, now we can see both of them. So I want to scroll this to the side. Scrolling until the 15th passenger. We couldn't see something, but now as you can see, we have a different request, which is page number 3 with again size 5, and we have the data, and it is added to our adapter and at the same time to our recycler view. And if I do it one more time, as you can see, one more request is sent with page number 4. If you keep going and keep going, it will never end until the API does not have any more data. And as you can see, we have the 14th page right now. And it is the same case for the vertical one. If you go down, let's see, it is page 4 right now. And if you go down, it is page 6 and so on. Okay, so our paging library works correctly. And after you implement it, and if you want to check just like me, you can just look at the logcat. It's a very simple solution. And I'm actually very convinced about our application right now.
Okay, so we implemented pagination and all the passengers are happy right now. So thank you all for watching, and as always, see you in the next Hippo tutorial.